Hello there. Welcome to the world of recursive SQL. Are you wondering what is recursive SQL and why should you learn it? Let's look at this typical org hierarchy. King is direct supervisor of Kosar and Dihan. Kosar is direct supervisor of other 5 employees reporting to him. Among them, Greenberg and Higgins have employees reporting to them. Likewise, Hannard reports to Dehan and there are employees reporting to Hannard. This hierarchy has 4 levels. Consider you got a requirement to write a SQL which shows Kosar and all the employees reporting to him. Let's try writing this SQL. Let's review employee table first. This table contains 107 employees. It has employee ID, first name, last name, email, phone number, hire date, job ID, salary, commission percentage, manager ID and department ID. Kosar employee ID is 101. So let's put it in where clause. Let's say either employee ID or manager ID is 101. Run the SQL. SQL returns 6 rows. Result contains Kosar and employees directly reporting to him. Let's review the hierarchy again. There are 5 employees reporting to Kosar. SQL is returning those employees. However, there are 5 employees reporting to Greenberg and 1 employee is reporting to Higgins. SQL is not returning those employees. To get all the employees, you need to enter employee ID of Greenberg and Higgins in the SQL. Now you get all 12 employees. However, your SQL to work, you had to know the employee IDs of managers reporting to Kosar. This will be difficult in real world. Also, what if there is a new employee who will report to Kosar and who will have employee reporting to him? In that case, you will have to change the SQL again with employee ID of this new employee. What if there are more than 4 levels? In real world, you might have scenario where more than 4, 5, 6, even 10 levels are involved. Your simple SQL will not meet the requirements in such cases. You need recursive SQL. This is just a simple case of org hierarchy. In real life projects, you will come across various such requirements where recursive SQL will make your life easy. It's time to rewrite the SQL. Remove the where clause and add start with employee ID and put employee ID of Kocher. Also add new line connect by prior employee ID equals manager ID. Run the SQL. Here you go. Now you have the output fulfilling the requirement. Result contains all 12 employees. It shows Kosar and all other employees under him in the hierarchy. Wondering how this magic happened? Let's understand this. Let us review the SQL along with the hierarchy and understand how it works. In the SQL, it says start with employee ID equals 101, which is employee ID of Kochar. With this clause, SQL got its starting point in the hierarchy. Kochar became the root label for the result. Next line in SQL is connect by prior employee ID equals manager ID. In the hierarchy, it moves to the succeeding level and compares the manager ID of employees at this level with the employee ID of Kochar, and it finds 5 employees: Greenberg, Wales, Maveris, Baer, and Higgins. However, it does not stop here. It moves to succeeding level in the hierarchy. Now, prior employee ID is employee ID of employees in preceding level, that's Greenberg's and others. It looks for employees whose manager ID is same as employee ID of Greenberg, Whelan, Maveris, Baer, and Higgins. And this is how it finds employees reporting to Greenberg and Higgins. It acts like a loop and keeps scanning through succeeding levels in the hierarchy until it is at last level and there are no more records to fetch. This is how connect by works. Interesting, right? So much can be accomplished with just 2 lines of a SQL. It is just the beginning. You are up for wonders in next lectures. After you add connect by clause in SQL, you can enhance it with several pseudo columns and options. This is SQL from the previous lecture. What if you get a requirement to show level of each employee in the hierarchy? You just have to add word level in your select statement. Add level in your SQL and run it. Notice it shows 1 for Kochar. However, Kochar is at second level in the hierarchy. What do you think? Why SQL is showing level value as 1 for Kochar? Let's look at the SQL again. Notice the line start with employee ID equal 101. That is employee ID of Kochar. Your start point is Kochar, hence it shows level as 1. Remember, the value in start with becomes the root for your SQL. Review the result again. For Kochar, level is 1. People reporting to him level is 2 and thereon. Now you know how level works in Connect By. Good job! Now you know how level works.
Congratulations, you are making very good progress. So far, you wrote your first recursive SQL using connect by and level. There is one problem with the result though. The data is not ordered properly. It starts with Kochar, then it shows Greenberg, followed by employees reporting to Greenberg, and then it shows Whelan, Maveris, Baer, and Higgins. There are couple of problems here. First problem is that employees are not ordered by their last name. I want to see Kochar first, then employees reporting to him ordered by last name. Also, employees reporting to Greenberg should be shown just after him and should be ordered. How to achieve this? Welcome to this lecture where you are going to learn about order siblings by. Add order siblings by last name and rerun the SQL. Review the result. Kosar is first. Next is Bayer and then Greenberg. Then you have employees reporting to Greenberg, all of them sorted alphabetically. Looks good. After that, Higgins, Geertz, Maveris, Whelan, all coming alphabetical order. All of them sorted properly as we desired. Problem solved. This is how order sibling by works. Good job! Now you know how order siblings by works. Keep the momentum going. There are other features to learn about. See you in next lecture.
So far, so good. You got Kocher and all the employees reporting directly or indirectly to him along with the levels in hierarchy. You ordered the results based on the last name of employees. However, it is still not so user friendly to comprehend. For example, if you want to understand the complete hierarchy for Gitch with employee ID 206, you need to look at the level his manager ID 205. Go to the manager Higgins that 205 record, find his manager, Kocher, and then build the complete hierarchy, that is Kocher, Higgins and Gitch. Wouldn't it be better if you can just get the details as one more column for the employee ID 206 and other employees? Like you have level, can you not get just one more column added which shows the complete hierarchy? You will be surprised how easy it is to do. Welcome to this lecture. You are going to learn about sys connect by path in this lecture. Go ahead and add sys connect by path in your SQL select list. Enter sys connect by path in bracket last name and /. Let's surround it with substring clause. Let's display first 100 characters in the hierarchy. Run it. Here you go. Now you see complete hierarchy for each record in the result. Let's replace / with dash. This is how you can select the delimiter in the hierarchy text. Looks good, right? Good job. Now you know how to use sys connect by path.
So far, you got the complete hierarchy by using sys connect by path. How about if you want to just see the root of the hierarchy? There is a pseudo column for that. It's connect by root. Welcome to this lecture. You are going to learn about connect by root in this lecture. Add connect by root last name in select list of the query and run it. It shows last name of the root in the hierarchy based on start with in your query. You added only last name of root. Using the same pseudo column, you can show employee ID of root or manager of root. Basically, you can put any table column value for the root record. Add root employee ID and root manager ID. Remember, the root here is not ultimate root in the hierarchy. It is based on start with in the SQL. Let's change the start with to employee ID 100, who is ultimate root of the hierarchy. Here you go. Now the root is king. As king is ultimate root, the manager ID for him is null, empty. Likewise, if you change the employee ID to 120, that's Vase, he becomes the root and only employee reporting to him is shown in the result. This is how connect by root works. Awesome. Now you know how connect by root works. Now it's time to explore grains of hierarchy. Add connect by is leaf in the select list of your SQL. Run it. Connect by is leaf shows 0 for parents and 1 for grains. It shows 1 only for lowest grain and not intermediate children in hierarchy. It shows 0 for Kosar because he has employees reporting to him. Likewise, it shows 0 for Greenberg. But it shows 1 for Favier, Sain, Skiera, Urman, Pop, Wellen, Mavericks, Beer because there are no employees reporting to them. They are ultimate children in the hierarchy. They are ultimate grains. Good job. Now you know how to use connect by leaf. It's time to talk about an interesting possibility. What if Kocher reports to Geach? Believe me, such hierarchy is possible in real world. If you come across such situations, what complexity it will bring in connect by SQL and how will you resolve it? It's time to look into this situation. Here you go. With the list of employees, manager ID, level and path. Employee ID for Kosar is 101 and his manager is 100. Employee ID for Girs is 206 and his manager ID is 205. Change the manager ID for Kosar to 206. Run the same SQL now. It is completing in error. This is happening because the SQL is going in infinite loop. You need no cycle clause to break this loop and make the SQL work. Here you go. The recursive SQL is working after adding no cycle condition. Add connect by is cycle in the select list. Connect by is cycle shows 1 for the record which were creating infinite loop. It shows 0 for other records. This is how you can find the record causing the loop. Revert the manager ID for Kosar and rerun the same SQL. Here you go. All the records are showing connect by is cycle value as 0. Congratulations! Now you know pretty much every options in connect by SQL.